So here's the demo for interactive prediction framework. Let me upload an image first. So I upload an image of CR having lung lesions, and you can see a very small dot here, and we can try to ask model to predict the result. And basically, we found that the model tried to predict between three classes: healthy, non-tuberculosis, and tuberculosis. You can also see here that the model is uncertain between these two classes, as they are giving them like a nearly equal score. And here are the explanation of the model having the concept. And you can see the similarity map here on the highlight region of the left-hand side image. You will see it is strongly relevant to the same segmented area in the prototype sample at the right-hand side image. In other words, the model is saying that this area of the image is similar to this area of prototype sample with similarity or confidence score of 0.7. We found that it is quite correct because it is indeed a confirmed lung lesion case. And this is how the concept of lung lesion works. What if we scroll through the explanation right about where the model thinks that there's a fracture present on the image? This is quite correct because we can see there's almost no fracture here, no broken bone here. So as a doctor, you can reject the concept of fracture because that is wrong one. We can choose to ignore fracture and let the model predict again. And it turned out that the model is leaning toward to conclude tuberculosis after we reject the concept of fracture. And we all know that fractures is broken bone, which is caused by a physical external sources rather than a disease like TB. And it is very reasonable if we reject fractures, and the model now would know that it is more certain of tuberculosis because doctor actions of rejecting fracture. On the other hand, lung lesions is also a very typical feature to detect TB. But what if we reject this? And we can see here if we reject a lung lesion, then the model does not find any signal of TB anymore because it is largely relying on the lung lesion feature and it now has no evidence to conclude a TB case. So that is how doctors are interacting with the model concept to calibrate the model predictions. Let me show you another sample of interacting with spatial dimension of the image. So here's an image of a patient having tuberculosis, and they also have a very clear feature of opacity here with an indicating fit around here. This is very relevant feature of TB, and let's see the relation of the model first. So the model also think that the TB with a very high score, but it's still some area for non-TB to raise. And as a doctor, you still want the model to focus more in this area. And by drawing a positive parent box over here, like the screening is showing, by this way, we are telling the model to focus into this area to make the prediction rather than the whole image. By marking the positive area, the model is now entirely confident that TB is showing a confidence score of 100%. So what if we do it another way around? We know that this area is a feature of TB, but we keep drawing a negative area over this. And when we are doing like this, we are telling model to ignore the area to make the predictions. Let model predict again. It can be seen that the model now no longer thinks TB has the highest score. In contrast, it is focusing on non-TB class. So it means that when we tell the model to ignore the actual TB feature by interacting with the spatial regions, we now can very confident that this is the clue that the model is using for the TB class. So let me show you one more example. If we draw an active routing mouse over the entire image, what would happen? So when we do this, the model now is very uncertain, and between the three classes because we are telling it to ignore everything. You may think that the model is likely lead toward the healthy class, but actually it is showing the same score of three classes because it is confused and don't know which conclusion is over other. So that is an end of our demo, and thank you for listening.